Good afternoon, and welcome to NASA's Lunar Delivery Readiness for the agency's Commercial Lunar Payload Services, or CLPS initiative, and Artemis program. I'm Antonia Jaramillo with NASA's Office of Communications. Carrying NASA science, Astrobotic's Peregrine lander is scheduled to launch aboard United Launch Alliance's Vulcan rocket at 2:18 a.m. Eastern Time, January 8th, from Launch Complex 41 at Cape Canaveral Space Force Station in Florida. This will mark the first commercial robotic launch to the moon's surface. Recently, teams with NASA and Astrobotic met to confirm all NASA payloads flying on board are go for launch. Here to talk with us about the NASA Science and CLPS initiative are Joel Kearns, Deputy Associate Administrator for Exploration with the Science Mission Directorate at NASA headquarters; Ryan Watkins, Program Scientist with Exploration Science Strategy and Integration Office at NASA headquarters; John Thornton, CEO with Astrobotic; Gary Wentz, Vice President of Government and Commercial Programs at ULA; and Melody Lovin, Launch Weather Officer at Cape Canaveral Space Force Station's 45th Weather Squadron. After brief opening comments from each of our speakers, we will take your questions. You can enter *1 on your phone to be entered into the question queue at any time. Your phones are on mute now, and the operator will open your mic when we're ready and close your mic after you ask your question. We ask that you please stick to one question and identify to whom your question is directed. Shortly after we conclude, you can listen to a replay of this teleconference online. First, we will hear from Joel Kearns. Joel?
Thank you, Tony. At NASA Science, we're really excited to be only a few days before we send American science to the moon, the surface of the moon, for the first time since 1972 in the Apollo 17 mission. And we're doing it a new way. We're doing it instead of NASA having a mission, our traditional and very successful way, which you've seen used on Mars and space telescopes and other major robotic scientific efforts. We're doing it with American industry. Under our Commercial Lunar Payload Services initiative at NASA, NASA pays industry to put NASA experiments and payloads on their missions and get them to the surface of the moon and get them our data back. And we think that this is a great approach to leverage entrepreneurship and innovation in the American industrial base. We think that it's going to allow us to do more frequently, a more cost-effective, and a more rapidly accomplished trips to the lunar surface to prepare for Artemis. And we think it's going to help build eventually a group of service providers that can do that, not just for NASA, but others in the United States and the world, and eventually build a larger lunar economy. But I have to tell you that it's a really difficult thing we've asked industry to do. You know, success of every attempt isn't assured, but we know that the companies that have agreed to do this are very technically rigorous. They're very hardworking. They've been thinking about this for a while, and now we have the first of those companies ready to fly Astrobotic Technologies of Pittsburgh for Peregrine Mission 1. At NASA, we did a lunar delivery readiness review where we looked at the readiness of our 5 NASA scientific investigation payloads that Peregrine will carry. We probed them to make sure we were ready operationally, that everything was ready with them being integrated on the Peregrine lander, and we're go for this launch. And this will usher in not only great new science for NASA in the United States, but the first test of this new model where it's not NASA's mission. NASA is being carried to the surface of the moon as part of a commercial mission with a commercial launch vehicle. And we'll also, in addition to the NASA experiments being carried, there will be experiments carried from other organizations that aren't NASA. So we're really looking forward to this in the next couple of days. Thank you, Tony.
Thank you, Joel. We'll now toss it over to Ryan.
Thank you, Tony. Like Joel mentioned, Astrobotic has 5 NASA-sponsored payloads that will make important contributions to lunar science and exploration. This suite of payloads will collect data on the lunar exosphere, volatiles on the lunar surface, as well as the radiation environment, all of which will help us better prepare for sending crewed missions back to the moon. Just to kind of briefly run through what those 5 payloads are, we have a laser retroreflector array, or LRA. So this is going to be a collection of 8 retroreflectors, mirrors, that will enable precision laser ranging, which is a measurement of the distance between an orbiting or landing spacecraft to the actual LRA on the lander. So this will function as a permanent location marker on the moon for decades to come. And the PI for that payload is Dr. Zhuai Sun out of NASA's Goddard Space Flight Center. We also have the Linear Energy Transfer Spectrometer, or LETS. This is a radiation monitor that will be measuring the radiation environment during lunar cruise, lunar orbit, as well as on the surface of the moon. And the PI for that is Ed Simonis. We also have a few spectrometers. We have the Near Infrared Volatile Spectrometer System, or NIRVIS, which includes a spectrometer context imager and a long-wave calibration sensor. And they'll be measuring surface and subsurface hydration, so think H2O and OH, as well as CO2 and methane, while also looking at the surface morphology and surface temperatures. So the payload PI for that one is Dr. Tony Colapri from NASA Ames. And then we have our Peregrine ion trap mass spectrometers for lunar surface volatiles, or PITMAS. This one will characterize the lunar exosphere after descent and landing, as well as throughout the lunar day, to better understand the release and movement of lunar surface volatiles. And PITMAS is actually a partnership between NASA, the Open University, and the European Space Agency. And the PI for that is Dr. Barbara Cohen from NASA Goddard. And then finally, we have our neutron spectrometer system. This one will determine the abundance of hydrogen-bearing materials, as well as the bulk regular composition at the landing site, and look at any time variations in the volatile abundance during the diurnal cycle. And this was being led by Dr. Rick Elphick out of NASA Ames as well. So we're really excited about the science we'll be getting out of these payloads once they're safely on the surface. Back to you, Tony.
Thanks, Ryan. Very cool science indeed. We'll now go ahead and pass it over to John.
Awesome. It's hard to put into words how excited the company and Astrobotic is for making this first mission back to the surface of the moon since Apollo. This is a moment 16 years in the making. A lot of challenges that we've had to overcome along the way. A lot of doubters. When we started in Pittsburgh, the idea of building a space company, much less one to go to the moon, was completely foreign and alien. And folks certainly and literally laughed at the concept. But 16 years later, through a lot of hard work and a lot of dedicated people and just enough people that believed in us along the way, here we are on the launch pad. I was out there just this morning, and it gives me goosebumps just to think standing under a 200-foot tall launch vehicle with a lander that was built by thousands of people contributing at Astrobotic, and our suppliers and our partners and all of the contributors of the payloads, culminating in this one moment, sitting on top of this launch vehicle, getting it ready to light up on Monday. Just an exciting moment. The lander will take off from Launch Complex here in Florida. It will go directly to translunar injection, where the lander will start its job, and we'll do trajectory correction maneuvers from that point out to the surface of the moon. We will have a intended landing time of February 23rd, so just about a month from now. And along the way, we're going to spend a little time in lunar orbit, making sure that the local lighting conditions are correct. We're waiting for local sunrise. Once we begin descent, it's about 1 hour down to the surface. It will be exciting, nail-biting, terrifying all at once, and a whole range of emotions. Once on the surface, that's when surface operations begin, and the 20 payloads, the customers from all over the world, will be on board that mission and deployed. 6 new nations will touch the surface of the moon for the first time, and we are just so honored and pleased to be a part of those stories, those Apollo moments for the nations flying with us.
Thanks, John. We'll hand it over to Gary now.
Thanks, Tony. Good afternoon. I appreciate the opportunity to be here to talk with you guys today. On behalf of the team at United Launch Alliance, we're excited to be here as we prepare to launch not only our first certification flight test of the Vulcan Centaur, but this historic mission for Astrobotic and NASA. We're really honored to be their ride to space. Yesterday, we completed the launch readiness reviews. They were successful, and all teams gave us a go to proceed. Following that, this morning, we rolled the vehicle to the pad, as John mentioned. Everything is proceeding nominally there, and we're on track for a planned 02:18 a.m. local Monday morning launch. We're not working any issues. and the count will resume around 3 p.m. local on Sunday. This Vulcan flight test will deliver the Peregrine commercial lander into a highly elliptical orbit more than 225,000 miles above the Earth to intercept the Moon, and will also carry the Celestis Memorial Spaceflight payload that will be transferred into deep space with the Centaur following the mission. It will remain affixed to our Centaur 5, and it will be placed finally in a hyperbolic orbit around the Sun following deployment of the Peregrine spacecraft. Following spacecraft separation, we'll use this opportunity of this flight test to validate a lot of our future mission objectives. Following the upper stage disposal burn that escapes the Earth orbit, the Centaur 5 will undergo about 2.5 hours of special tests to simulate a long-duration on-orbit mission profile like those needed for our direct-to-geo missions that we perform for other customers. This demonstration will capture thermal data. It'll enable us to anchor our models for extended duration coasts, and we'll also conduct a third start of the RL-10 following a long coast. This is the first of 2 test flights that we have planned in order to obtain our full certification with the Space Force. And we've worked in close partnership with the Space Force throughout not only the design, the development, and testing and production of this vehicle, but its final processing as we develop this capability to give the nation assured access to space. So in conclusion, I want to thank all our mission partners for partnering and joining us through this journey over the last decade. Also want to thank our ULA team and our supplier partners, and looking forward to a successful flight test on Monday. Thanks, Tony.
Thank you, Gary. And now lastly, but definitely not least, we'll hand it over to you, Melody.
Thank you, Tony. So let's talk about the weather. All right. So I'm thrilled to tell everyone that we had favorable weather this morning, which allowed a successful roll to pad today with the high pressure situated over the Carolinas. However, we do have a bit of a change coming tomorrow. We do have a cold front moving through the Florida Peninsula. We're expecting some strong winds and some heavy rain with that. However, the good news is for Sunday, high pressure builds in behind that strong cold front, and that will create great weather conditions for the opening of the initial launch window late Sunday night. Our probability of weather violation is only 15%, which translates to an 85% go for weather. Our primary concern for the opening of the launch window Sunday night will be the thick cloud layers rule. Temperatures should be right around 60 degrees with northerly winds generally around 15 knots. Okay, as we look to the 24-hour and the 48-hour delay, however, there is another big change for that. We are expecting a strong cold front to approach on Monday and sweep through the Florida Peninsula on Tuesday. So for Monday, we are expecting that moisture to increase throughout the day, and also our winds are going to substantially increase as well. So because of that, unfortunately, the weather for the 24-hour delay does not look quite as optimistic. We're looking at a 60% probability of weather violation, which translates to a 40% go. That our primary concerns for that day will be the ground winds, cumulus cloud rule, and also the thick cloud layers rule. If we do need to utilize the backup day on Tuesday evening, that will be right around when we're expecting the frontal boundary to move through the area. It could move through right prior or just after the opening of the launch window. Our probability of violation for that day is it's 55%, which translates to a 45% go for weather. And the primary concerns will be the same as the Monday night attempt, which is ground winds, cumulus cloud rule, and thick cloud layers rule. I should mention for Monday night, temperatures should be around 70 degrees with east-southeasterly winds generally around 25 to 30 knots. And that changes a bit as we look to a Tuesday night attempt with a temperature down a little bit, down to 63 degrees with west-southwesterly winds generally around 30 knots. So with that, I'll go ahead and pass it back to you, Tony.
Thank you. We will now begin the question and answer portion. Please remember to stick to one question and identify to whom it is directed. If we have time, we'll allow reporters to ask a second question. Again, you can enter *1 on your phone to be entered into the queue at any time, and you can enter *2 if you'd like to be removed from the queue. We will now begin with our first reporter, and we have Marcia Dunn with the Associated Press. Hey, Marcia, can you hear us? All right, looks like Marcia's having some technical difficulty, so while we wait for her to hop back on, we'll hop over to our next reporter. And we have Irene Klotz with Aviation Week. Irene, can you hear us?
I can hear you. Hey? Hello?
Hi, we can hear you. You're ready whenever you are.
Okay, thanks very much. Hi, this question is for either Joel or Ryan. When the CLPS contract for this mission was awarded like 4.5 years ago, it was at a cost of $79.5 million and was to fly 14 NASA payloads. Can you just tell us if there's been any change in the contract value and maybe a quick summary of why the NASA payload component changed so much?
Sure, this is Joel. I'll answer that. So since the time the contract was originally awarded, we all went through COVID and we went through all these supply chain issues that we had coming back from COVID that affect all different industries. So NASA did accept requests for equitable adjustment changes in the contract value because of the nature of the COVID emergency. But in addition to that, later, after we'd awarded the contract, I believe in 2022, we had gone forward to ask Astrobotic to change their landing location. At the beginning, when we awarded Astrobotic this contract, we allowed them to select the location they would land on the moon, and we also gave them a candidate list of science payloads that they could choose from of what payloads to send to the moon. We decided after several years of looking at the additional CLPS landings that we had awarded to go to different locations that we wanted Astrobotic to go to one particular location on the moon so it would complement future scientific work, and they agreed to do that. In addition to that, I think naturally, as different companies have matured their landers designs, they have much better ideas of the performance of their space vehicles. And based on the performance of the rocket engines being used for the Peregrine mission, NASA elected to remove some payloads, and again, agreeing this with Astrobotic, to make sure that the amount of cargo that we had on the mission overall was good for the performance of the vehicle. And we're happy with that approach, and that's how we're going forward for this launch.
Thank you so much, Joel. I do want to just give a quick notice to all of our reporters on the line. We did have a quick little technical issue, so for all of our reporters that had dialed *1 to be entered into our Q&A, unfortunately, you did get accidentally removed. So if you don't mind just dialing *1 again if you would like to ask a question, we'll then go ahead and call on you. In the meantime, we will see if Marcia Dunn with the Associated Press is back and able to hear us. Marcia, can you hear us this time? Looks like we still don't have Marcia, so we'll move to our next.
Can you hear me?
Oh, we can hear you, Marcia.
Oh, thank you. My question is for Mr. Wentz. I'd like a little more clarity on the launch period. Could you try to launch all 4 days? Talk a little bit about what I don't know if you can do 4 days in a row. And if you don't get off in the 4 days, when would the next launch period be? Thanks.
Thanks, Marcia. Let's see. So on January 8th, we're targeting the launch at 2:18 in the morning, local. It's a 45-minute window. We can do a launch on the 9th of January at 12:15 a.m. local, and that's a 9-minute window. The 10th is right around 12:12 a.m. local, and it's a 1-minute window, so that one's pretty tight. And then the 11th of January is a 12:14 a.m. Launch with a 3-minute window. Those 4 days are the opportunities. Obviously, as we go through the flow, the number of back-to-back attempts will depend upon how far we go into the count, how much consumables, commodities we actually expend in the scrub process, assuming that it's a weather delay or something like that.
Thank you, Gary. Again, as a reminder for all of our reporters, if you have a question, you can please enter *1 to be in our Q&A. I promise this time it won't drop, or we'll try our best. Next up, we have Bill Harwood with CBS. Bill, can you hear us?
Yes, I can hear you. How about me?
We can hear you loud and clear.
Okay, thank you. Gary, this is a follow-up to Marcia's question a little bit. Does the ascent timeline change from day to day, or are the ascent events like they're listed in ULA's website, are those solid regardless of which day you launch? And the reason I'm asking is, NASA had a variable azimuth window for Artemis 1 where it changed pretty dramatically some of the events, and I'm wondering if anything like that's going on with CERT 1. And also related for you or for Astrobotic, is there any kind of timeline available of major events on the trajectory post-SEP through landing, or are all those events, variable? I'm just trying to get a sense of when burns are planned, the orbit they're going to get in, et cetera, et cetera. Thanks.
Thanks, Bill. So from our perspective, there is some change in the events. There's also differences depending upon the day on coast durations between burns that will go through day by day. So there will be some variability, and we'll be able to provide you those as we go through the process. And I'll turn it over to John relative to the post-SEP events.
Yeah, thank you. So post-separation, we've got, first thing we're going to do post-separation is we're going to initiate communications and power up the spacecraft, and then we're going to be doing a maneuver to point the spacecraft towards the sun. All of that happens within the first few hours of separation. I don't have specific timing on that. And then we're going to do a phasing loop around Earth as we head out towards the moon. There are going to be some trajectory correction maneuvers along the way. They are not currently scheduled because we're going to adapt to what the trajectory result is on launch. And then we go into lunar orbit. We're going to start at a high elliptic orbit and then go to a medium elliptical orbit and then circularize down to 100 kilometers. And at that point, that's our final orbit, and we'll have about 1 hour down to the surface of the moon. And we can follow up with we've got some images and some trajectories we can follow up with. If you reach out to our press office, we can follow up with that.
Thank you. Next up, we'll go to Stephen Clark with Ars Technica.
Hi, Tony. Can you hear me?
We can hear you.
Great. Just wanted to follow up on a couple of questions that were previously asked. I'm not sure they were answered directly. For Joel, what is the new contract value with Astrobotic for this delivery? 70-something million when it was let a few years ago. I think Irene asked, what's the new value? Do you have that number available? And for Gary, also, when does, after the 11th, I believe, when does the next series of launch opportunities open for CERT 1 for Peregrine? Thanks.
Well, this is Joel. The current contract value for Astrobotic to carry the 5 NASA experiments to the moon is $108 million. Gary?
And the next opportunity following the 11th would be the 23rd of January.
Great. Thank you so much, both of you. Next up, we have Jeff Faust with Space News.
Hi, can you hear me?
We can hear you.
Great. Question for Gary. I'm just curious why the launch window on the 8th is at a different time and significantly longer than on the 9th, 10th, and 11th. I assume it's some quirk of orbital mechanics, but just curious why the 8th is so different from the other 3 opportunities. Thanks.
Yeah, it's all tied to the orbital mechanics and us being able to rendezvous for the lunar injection. Each day it varies pretty significantly. Some days we have longer windows, like the first day we've got the 45 minutes with 6 different targets that we can shoot for during that 45 minutes, and then subsequently they vary the number of targets, opportunities within the tighter windows. The opportunity on the 23rd, for instance, opens back up, and we go to a 39-minute window. So it just varies for us to get the mission delivered for the Astrobotic customer based on their landing site.
Thanks, Gary. Next up, we have Andrea Lenfender with the Houston Chronicle.
Hi, I have 2 questions for Gary. First, when did ULA start developing the Vulcan rocket? And second, on this mission, the BE-4 engines won't be reused, correct? But in the future, they could pop out and land beneath parachutes. Will anything else be reused? Thank you.
Yes, so roughly the development of Vulcan started about 10 years ago, and then the teams continued to evolve that design to where we are today. Relative to the BE-4s on this mission, they are not planned for reuse. The team is developing a concept similar to what we flew as a demonstration for the JPSS mission off the West Coast, where we used a inflatable reentry system to return the engines. That is a concept that we're looking at for future reuse opportunities of the BE-4s, and we don't have any plan for reuse of any other components.
Thank you so much. Just again, as a reminder to our reporters, we are still having some technical difficulties where we can't really see everyone who has their hand raised to ask a question. So again, if you do have one, please enter *1 to be entered into the question and answer portion. Next up, we will go to Marcia Smith with Space Policy Online.
So much. Can you hear me okay?
We can hear you.
Okay, good. I have a couple of clarification questions. One, there are 6 NASA payloads on this, aren't there? I thought someone said 5, but aren't there 6? And I also wanted to ask a more general question of Joel about how NASA looks at each of these CLPS missions, and if there's any way that you're trying to sort of integrate what goes on what lander. So you've got another one going perhaps next month with Intuitive Machines and several more this year. Do you have like a strategy of how you're putting these payloads on it, or is it sort of random as to where the contractor wants to go?
So to address your first question, there are 5 NASA scientific payloads that we've contracted Astrobotic to deliver, the ones that Ryan Watkins described earlier. There's also a component which NASA made available to Astrobotic, which Astrobotic is using. It's a technology called a NASA Doppler LiDAR system. And Astrobotic is using this as part of the actual Peregrine spacecraft. And that's actually not part of commercial Lunar Payload Services. That was agreed to be provided to Astrobotic as they were already developing their Peregrine lunar lander years ago. The second is that we started off with a strategy on CLPS that we would first, with the initial landers, fly groupings of individual scientific instruments that by themselves would make particular measurements individually that were very important to make, and they could be done pretty well anywhere on the moon. But as time went on, we then started putting together more sophisticated instruments and actually naming the landing locations that we wanted the instruments to land on. So in particular, since 2021, we've done an annual competition called Payloads and Research Investigations for the Surface of the Moon. And once a year, we pick 1 to 3 suites of instruments, scientific instruments and investigations. And based on that, we pick the landing location for the moon. And based on that, we compete for a CLPS landing to deliver those scientific instruments. We augment that with other NASA cargo. For example, cargo to demonstrate exploration capabilities or space operations tests like in communications, and that becomes what's called our CLPS task order that we compete with industry. So there is a there is a cadence that we're using in both of what type of science we're doing and where we're landing on the moon, kind of expanding capability and value from mission to mission, and also the combination of equipment that we're flying on particular deliveries. Now, any particular delivery for some reason might be shifted in time, so we don't have the deliveries laid out so that delivery X has to go a certain month, say number of months ahead of delivery Y. We've tried to make them, they are independent contracted deliveries by NASA to accomplish those goals. And I was reminded that in response to your first question, that the NDL, the NASA Doppler LIDAR, is a flight-controlled guidance and navigation sensor, but again, as I mentioned earlier, it's not part of the NASA Eclipse payload that we've complemented, that we have competed for Astrobotic to do for us.
Thanks, Joel. Next up, we have Jim Siegel with NASATech.net.
Thank you for taking my question, and good luck to everyone on the flight on Sunday or Monday. I have a question about the certification flight of Vulcan. Maybe this is for Gary, and perhaps Joel has a comment as well. Some might have expected that the first flight of this rocket might have been on a mission that wasn't as important as this one. And I wondered if you had a question or a comment about why you decided to launch with Vulcan on this particular mission. Thank you.
Well, this is Joel Kearns from NASA. First, I'll say that, again, to remind you, the Peregrine mission is Astrobotic Technologies' mission, and they selected United Launch Alliance for the launch vehicle. But I will also tell you that NASA has great confidence in the products of United Launch Alliance. The United Launch Alliance, through Delta and Atlas, has enabled some of the most groundbreaking NASA science missions that have been flown. But having said that, I'll turn it over to John Thornton and Gary.
Thank you, Joel. Yeah, so the reason we went with United Launch Alliance, we have the same belief in them as a company. They have a storied track record like no other on Earth, with decades of success under their belt. Vulcan has a new name, but it really is an upgraded Atlas V, so that gives us great comfort in that as well. They've been a fantastic partner to us over the years in development of this capability and in parallel with development of their rocket. At the end of the day, our budget is not limitless. We are constrained with an effectively firm fixed price. So what we are trying to do is create a new cost paradigm. And with that, we have to take a balanced set of risk approach to this mission, which means we have to selectively find ways to save money and to find ways to get the most value out of the dollars that we have. So for that, we chose United Launch Alliance's first flight of Vulcan because we believe so much in the company, and we're very, very confident that this mission will be successful. And of course, that came with some relief on the price, and that makes this mission possible.
And this is Gary. I'll go ahead and add that from a United Launch Alliance perspective, we're building on more than 120 years of combined Atlas and Delta experience. As we brought Vulcan on board and designed the systems, we leveraged the existing systems as much as possible from Atlas and Delta. In many cases, so for instance, like on the solid motors, those are a variant of the GEM 63 that we fly on Atlas today, and so it gave us much more confidence in our ability to fly that. When you look, Tori's put an infographic out, when you look, the only hardware that hasn't flown prior to this flight is the BE4 engine. All the other, or variants there too, have flown on either Atlas or Delta flights on missions for other customers. So that gave us confidence to be able to offer this to support NASA and Astrobotic's missions, again, leveraging the heritage and appreciate their confidence in our ability to deliver.
Thank you all. Next up, we have Lucy Auberg with AFP.
Hi, thank you. I believe my questions are for John. Just a quick clarification. Will the lunar landing still be planned on February 23rd if the launch is delayed by a few days to the 9th, the 10th, or the 11th? Will the lunar landing date stay the same? And then could you maybe talk a little bit about what it would mean for you, for Astrobotic, to be the first private company to land on the moon and the first American spacecraft to do so in 50 years, especially given that there is so much competition? Thank you.
Thank you for the question. So first, on the question of timing, is that it will be the same date if the launch window gets delayed. And the reason for that is that we are trying to land at a specific day and time on the surface of the moon, so we're waiting for local sunrise at our location. So on the way to that, we actually spend extra time in orbit just waiting for the sun to rise. So if we skip a few days or miss a few days on the launch window, we're just basically going to spend a little less time in orbit. It doesn't impact our mission for the window. On the second, in terms of what it means, it could mean a lot. We have an opportunity to be among the first commercial payload deliveries to the surface of the moon. To be leading America back to the surface of the moon for the first time since Apollo is a momentous honor that we're lucky to be a part of, and to potentially be the first to launch here coming on Monday is just huge. I mean, it's a dream that we've been thinking and dreaming of for 16 years as a company. We come from Pittsburgh. Pittsburgh is not a traditional space region or state, but we're making it that. We are building a new capability. We are bringing a new space state online, and I can't tell you how excited and proud Pennsylvania is of this mission and what it will mean. Pittsburgh comes from steel and has went through downturns in the 70s and 80s, and has since reinvented itself. And this mission is a representation that if Pittsburgh can land on the moon, Pittsburgh can do anything. So it really does mean a lot, and we're just so excited and that we have the opportunity. And we can't thank NASA enough for leaning forward and taking on the risk to roll the dice with commercial. It's worked out really well before, and I believe this program is a fantastic advantage and competitive advantage worldwide, that we can maintain our competitive advantage in space as a nation through commercial efforts like this. So I can't thank enough NASA for the opportunity to fly this mission, to be a part of it, to have joined together on this. And to be flying with the storied company ULA on this, it's storybook story. So just thrilled.
Thank you. Next up, we have Kristen Fisher with CNN.
Thank you very much. My question's for John. John, does Astrobotic have a response to the Navajo Nation's concerns about Elysium Space and Celestis' payloads? Specifically that landing cremated human remains on the moon they believe is disrespectful to their culture and religious beliefs? That's my first question. And the second one is just, are there any talk, any discussion, any worry that their concerns could somehow delay this mission and this launch, since they are bringing them all the way to the White House? Thank you.
Oh, thank you for the question. Our goal at Astrobotic is to make space accessible to the world, and we've been doing that by building relationships and collecting partnerships from people all over the world, from all backgrounds, all walks of life. We have 6 new nations flying on this mission that will be touching down on the surface of the moon for the first time. We've got 150 plus individual contributions to one part in particular called DHL Moonbox. As part of that, hundreds of thousands of people have contributed in various capacities. We have tried to do the right thing at every turn along the way on that, and as part of that, we've also been trying to make it accessible. I'm disappointed that this conversation came up so late in the game. I would have liked to have this conversation a long time ago. We announced the first payload manifest of this nature added to our mission back in 2015, a second in 2020. We really are trying to do the right thing, and I hope we can find a good path forward with Navajo Nation. Oh, and on the second, in terms of does it impact the mission or timing, that is way above my pay grade. The lander is on the launch vehicle, on the launch pad as we speak. days away from launch, and there's a lot of stakeholders involved in that launch now.
Thank you, John. Next up, we have Sean Hamill with the Pittsburgh Union Progress.
Thank you. Can you hear me?
Yes, we can.
Okay. My question is related to some of the prior questions for Joel. You mentioned earlier that part of the strategy in awarding this contract to commercial enterprises like Astrobotic is to build a group of service providers in these future missions in particular. What do you think Astrobotic, a 16-year-old company, getting this contract in a city, as John mentioned, does not have a lineage like, let's say, Cape Canaveral or cities in Texas? What do you think this means for them specifically, and then more broadly, the Pittsburgh region? Thank you.
Well, in a way, I have to turn that question over to John, who is more familiar with Pittsburgh and Pennsylvania than I am. But one of the strengths we have in the United States is entrepreneurship and innovation, and it's all throughout the United States. And another strength we have is a market economy of strong industry, right? This is such an interesting and invigorating thing to do. We're just really pleased at the companies that bid to be part of commercial lunar payload services. They all bring different strengths to the table. They have different approaches, and I would say that it's also a way to watch people do something new. We really are committed to this idea of buying a service from industry instead of doing it ourselves, because as you mentioned in the question, it will not only give us a group of service providers for us and others to tap into the service in the future, but it will help bootstrap and bootleg a future cislunar economy that America can participate in. So all these companies the various companies come from very different regions. Some are used to doing space, some of them space is new, but they all bring incredible excitement and innovative approaches and different ways to do business in the future. John?
Yeah, I can add to that. I think one perfect encapsulation of this is that Astrobotic is in the business of making space accessible to the world, and we believe in it so much, and we recognize that we are from a new part of the country doing this industry, that we created a nonprofit called the Moonshot Museum. We gifted part of our headquarters to it. You can actually go to it, and right through the window glass, you can witness the build of our landers on the other side of the glass. We did that to engage the community, to engage the state, to engage the city, and to share the thrill of excitement of spaceflight with the people of Pittsburgh and the region. And I can tell you that the response has been overwhelming. The foundation community donated millions of dollars for the development of the exhibit itself. The mayor, the governor have come and visited multiple times. The city of Pittsburgh, every time they show up, they can't believe that this is happening in their own backyard. It's something that's usually done at some far-off place, and you have to have a PhD to be in space, is what they believe. And we're breaking that barrier down. We're showing that for Pittsburghers that there's lots of jobs in space. Yes, you can be the PhD rocket scientist, but you can also be a technical graduate building the actual lander. You can be one of the suppliers, part of the supply chain, and we're waking Pittsburgh and that region up to that reality of this is a giant, hundreds of billion-dollar industry, and now Pittsburgh and the region can play too. And I'm hoping that the inspiration that Apollo had on an entire generation, that we're able to have some small percentage kind of impact, a small-scale version of that for the Pittsburgh region and Pennsylvania. And I think the Moonshot Museum is where we're seeing that happen in real time.
Thank you so much, both Joel and John. As a reminder, we also have Ryan Watkins with us on the call, and also Melody Lovin, just in case anyone has any other questions. We do have next up on the line Adam Kovac with The Messenger.
Hi, thanks so much for taking my question. This question's for John. I was wondering if you could speak a little bit about the profitability of this mission, whether this is a mission that's in the black, and what the profit margins on this mission might mean for future private ventures to the moon.
Well, I wish I could say it was in the black. But we're doing the best we can with the budget that we have, trying to make things work. The first time you do anything, it's hard to stay on budget, hard to stay on schedule. What matters most is success, and that's what we've poured all of our energy into for this mission. We've gone through all of our testing, environmental testing of the entire spacecraft, which is a really good thing that we went through those steps because we actually did find some small manufacturing issues that could have ended the mission, and we fixed them. So I can tell you that it really is our focus to make this mission a success, and we're doing everything that we possibly can to do that. Our hope is that success builds on itself and can turn new opportunities and bring new players to the market. And we're beginning to see that already. I mean, our first mission is a good example of that, with 20 payloads represented from all over the world. And we're seeing more come out of the woodwork, more opportunity. So I think we'll see more scientists, more space agencies, more companies being able to engage with their people in new ways. So it's a whole new world, and we're excited to be a part of that, and we're very excited for the opportunity to be a part of that. So I think the business will come in time as the market grows and matures in time.
Thank you. Next up, we have Ben Iannata with Aerospace America.
Hi there. I wondered if each of you could just go over any firsts in this mission. I don't mind the obvious ones, but I'm concerned about, if there are any less obvious that would, be interesting to technology people and people that are really into science.
Where to start?
Ryan Watkins, is there anything you would like to suggest as a first on the mission from a science point of view?
Yeah, that's a good question. I was just sitting here trying to figure out if we're taking any first science measurements. I would say, if we don't think about the specific science on this particular delivery, it's the first time we landed on the surface. The United States has landed on the surface of the moon in over 50 years now. And while it's not a first for us to land, it is a first. Obviously, the most obvious thing here for a commercial company to do it, using this method, I think is just super exciting. While some of the science investigations may not be like the first of their kind, we are going to a new location that we've never been to, landing right next to an area of silicic volcanism, looking at the Mare deposits that surround this really enigmatic complex on the moon. So we're going to get some measurements of a brand new area. So in that sense, that's a really exciting first for this particular delivery.
Yeah, I will add, this is Joel Kearns, I'll add that in addition to the business first and the programmatic first we talked about earlier with CLPS, that when we were asked earlier about the sixth item, which was the NASA Doppler LIDAR, that is a new Doppler LIDAR technology developed by NASA at Langley Research Center, which Astrobotic is using and demonstrating on this first Astrobotic mission. And I believe Astrobotic has a number of technology developments, some of which are reflected in payloads and some of which are reflected in work that they've built into Peregrine that they've done in concert with NASA's Space Technology Mission Directorate over the years, like terrain relative navigation, which I believe will be tested as that's a non-NASA payload on this mission. It's not part of the NASA CLPS activity, but I believe you're doing that as part of the mission for the first time.
That's right, Joel. That's just the beginnings of the firsts here. First launch of Vulcan, first launch of Peregrine, first launch of a commercial mission to go to the surface of the moon. It's the first launch of 6 nations flying to the moon, first launch for the Mexican Space Agency and UNAM, Links UNAM, the university that put that payload together. The first launch for Germany as a nation with DLR Space Agency and DHL behind it. The first launch for United Kingdom to go to the surface of the moon, first launch for Hungary, first launch for the Seychelles, and first launch for even other countries like Nepal. There's a piece of Everest going back to the moon because there was actually an astronaut that brought a piece of the moon to the peak of Everest, and now Everest is returning that, and that's in partnership with schools in the area of Everest. So the number of firsts are massive. And I think that's what makes it exciting. There's a lot of people looking to this mission, and a lot of meaning and connections that we've made with people all over the world. And I think that's going to keep eyes attached to this, and hopefully on a great success, we'll see a lot of people cheering the mission and all of our customers that have joined this mission.
Just checking to see if Gary with ULA had anything he wanted to add before we move on to the next question.
I think the majority has been hit on relative to this. Obviously, this is the first flight. That's very significant for us. But in general, I would just say, if you look through, I've been in this business for over 3 decades, and when I look at my peers and folks that I've worked with in the past, it's not that frequent in our career that we see these kinds of developments coming forward and get the opportunity to participate or develop these systems. So when you look at the launch vehicle, you look at the lander, it was our fathers and perhaps our grandfathers that developed these systems in the past. There's very few folks in the workforce today that had firsthand activity during the development of, say, Space Shuttle. And so when you look across the community, I think this is an opportunity for all the folks in industry and the new entrants, our entry-level professionals to gain some firsthand experience with the development, design, test, and now flight of first-time hardware.
Thank you. Next up, we have Peggy Hollinger with the Financial Times.
Thank you very much. Can you hear me?
Yes, we can.
Super. All right. Well, thank you very much for this, and it's all very exciting. Before I ask my question, I just want to say I don't want to be the doomster. I'm very excited, and I really hope you succeed. But we have seen failures. We have seen mid-flight failures and explosions. What happens then if, God forbid, that should happen to this flight? What's the next step, and when can the next flight be, and what does it mean for each of the participants?
I'll go ahead and toss it over first to ULA. If Gary, you want to go and kick it off?
So we go through a pretty extensive process as we're getting ready for flight, checking everything out. Safety and mission success are first and foremost in our DNA and the way we operate. Yes, we have experienced in the past anomalies and observations, challenges, just like everybody else in the industry. We will, if something along those lines was to happen, we'll go through a detailed investigation. We'll seek to understand what the challenges or challenge was that caused that, and press forward to fix it and get back to flight as soon as possible. With that, I mean, we'll just have to take it as it comes. We've done everything, the series of reviews. Wednesday, we went through a detailed engineering review, went through all the open significant anomalies that we saw during processing and build of the hardware, got very comfortable that we were okay to proceed with that. And then we've went through the launch readiness reviews, looking at safety of the public as well as the safety of personnel and the hardware. And we were confident coming out of those reviews to give a go to proceed. We've done thorough testing from a qualification and acceptance perspective of the hardware and the systems that we have out on the pad. We concluded a flight readiness firing end of last year and did a wet dress rehearsal of both stages. And so our confidence is really high that we've gone through all the testing, all the checkout that's physically possible, and we're at a point now where we need to fly. And no doubt we will learn a lot of things about these systems. Like I said, we're leveraging over 200 combined years of Atlas and Delta experience. We've put
the best of the best technologies that we deemed were appropriate in the Vulcan, and look forward to the observations and to continue to learn and move forward.
This is John from Astrobotic. You're definitely correct in that flying to the surface of the moon and operating lunar missions is a very, very challenging business to go about. If you look back in the course of history, only about half of those missions have been successful. And most of those have been funded by superpowers with vastly larger budgets than this mission has been granted. So it's a really, really big challenge. And we recognize that, eyes wide open. I think the way to think about this is one of a series of lander missions going back to the surface of the moon. CLPS has awarded around 10 missions to go back to the surface. This is just one of those missions. This movement has a lot of momentum around it. There's a train of next launches behind me. We have our own launch coming up later this year. So in the event that we have a bad day somewhere along the mission, we're going to be gathering all of the data that we received up to that point, and we're going to learn from it, and we're going to help industry learn from that, and we're going to get smarter, and we're going to be ready for the next one. So that's the way to be thinking about this. This is much more like the commercial development of launch vehicles than a multi-billion-dollar specialty science mission. So it's a new world, and this is our approach. And we're hoping for the best, but we know what the odds are that we're up against and the challenging environment we're headed into.
And this is Joel Kearns. In my original comments, I pointed out how difficult it is to have industry land on the moon. But we're really confident U.S. industry can do this, and we're confident in our approach. CLPS is part of our approach of leveraging partnerships, in this case industry, to accomplish national space goals, in the short term for Artemis, and in the longer term for Moon to Mars, and further out into the solar system. So we're really confident in the approach. Of course, we'll react to what happens. We'll want to understand how industry will go forward if something doesn't go quite right. But overall, we believe we're on the right trend and the right plan.
Thank you all. We have time for one final question. Stephen Clark with Ars Technica, your line is now open.
Hi, I think my question is for Joel. The IM-1 mission currently targeted for launch in mid-February. If that launch happens around that time, do you happen to know when that would land, how close in proximity time-wise to the Peregrine landing? And would that cause any concerns or constraints that need to be deconflicted with the Deep Space Network?
No, I think you would have to go talk to Intuitive Machines to talk about their plans for their first CLPS mission, Intuitive Machines 1. Today, we're just focusing on Peregrine Mission 1 with Astrobotic technology.
And I will say, any questions directed towards Intuitive Machines and their spacecraft can be directed to their communications team if you want to just send us a note if you need their that contact info. Thank you all to everyone who submitted questions, and thanks to today's briefers for taking the time to discuss NASA's CLPS initiative. You can listen to a replay of this teleconference online by visiting the Media Resources tab at nasa.gov/CLPS. As a reminder, Astrobotic is scheduled to launch aboard ULA's Vulcan rocket at 2:18 a.m. January 8th. Our live launch broadcast will start at 1:30 a.m. and will air on NASA Plus, NASA Television, the NASA app, and the agency's website. Thanks again, and that will conclude our call.